All right. Let's discuss this latest lecture note that I posted last week. I think this week lang. So forgive me for I am not able to meet with you due to my schedule, no. Di gid siya makuan. So I am afraid nga during sa atong discussion manggod is na manawag ana. So that is why I opt to make a lecture video na lang, no? So that ma-arrange na ko akong time and yeah. And what if you have questions, don't hesitate to ask no in the GC or in the um, uh, Google Classroom. So, uh, we have these updates on Chapter 2, the Minimum Design Loads National Structural Code of the Philippines, or the NSCP 2015 Volume 1. So what is this update no, on Chapter 2? So there are significant changes to Chapter 2 Minimum Design Loads from NSCP 2010 to changes no to NECP 2015. Load combinations, number one, load combinations 4 are changed due to the use of strength-based wind loading based on ASCE 7-10. If you will notice or if you happen to read no the NECP 2010 and compare it with NECP 2015, grabe ang pag-change no especially sa wind load, pag-change of there actually taas na kayo nga kuan kanang pages or process sa windload in the NEC 2015 and dako na pud ang iyahang kilometer per hour that will be used in the design. So there are actually many changes especially sa wind loading, no. Additional live load designations for parking, garage, and ramp live loading also. So there are changes also, and basic wind speed are revised based on the latest study, no. I am not sure but I think sa NEC 2015 it kuan na siya almost 300 km per hour na ang kuan ang design no wind speed to be used in the analysis. Then for communication towers, the ANSI or TIA, EIA 222G latest edition is fully referenced in the in SCP. Then near source factors are revised to consider distance to source less than 2 kilometers. So in the NECP 2010, there is no factor, no walay factor nga under sa less than 2 kilometers. So I think less than 5 kilometers ang naa dito, 10 kilometers and greater than 15 kilometers. To be distinct and with higher values, no revision of magnitude limits for seismic source type A, no, and use of spectral acceleration based on ASCE SEI 7-10 is recognized as an alternative procedure for determining earthquake forces, and the rest of sections in chapter 10 are unchanged with reference to NECP 2010 6th edition. But yeah, there are actually changes, but we are not after of the changes now from 2010 to 2015. What we are after of is the provision or the codes provided no by the NECP 2015 kay mo man ang latest, so we have to adapt the latest code, no. So actually change ang code, no. So that is based on the also code from the ASCE, no, kay ga-follow ta actually og American Standard nga code. So kung mag ACI, no, kung mag-update ang ACI, we have to also update our NECP. So there are actually kung tanaw ninyo, I posted in the Google Classroom the soft copy of the NECP 2015. So there are different densities, material densities of the different material. So for example, kani siya this is in sorry this is in kilometer per cubic meter. So concrete, makita ninyo concrete is nasa diri, or reinforced concrete for stone including gravel, that is 23.6 kilonewton per cubic meter, and so on and so forth with this specific material. So we have also the minimum dead loads of the different material in kilometer per kilopascal, kilonewton per meter square. For example, we have this floor fill, that is, for example, lightweight concrete per millimeter, that is 0.015 kilopascal. And yeah, for masonry, we have this masonry for concrete hollow blocks, units. This is unplastered. This one is unplastered. You have to add 0.24 kilopascal for each face plastered, like for example, you have this, the density of the CHB, concrete hollow block, is 19.6 kilonewton per cubic meter. So for no grout, then this is the grout spacing, and we have this thickness of the CHB. We have 100, 150, and 200 millimeters. Then for full grout, the density for, the minimum dead load for thickness 100 millimeter is 2.69 kilopascal. Kani siya is unplastered, then plus 0.24 for both sides, plastered, or both face plastered. You have to add 0.24 times 2. So that is the total dead load, minimum dead load for the concrete hollow blocks. Especially for wall. We have also this minimum this uniform load and concentrated live load. Depende sa purpose or use or occupancy. Like for example, we have these access floor systems the office use. For uniform load, you have to use this 2.4 kilopascal. So if it is for computer use, you have to use the 4.8 kilopascal. So we have to refer this table in the 2015 NCP and be adapt sa or implemented or used in the if you're going to use TAAD in your design, then we adapt the loads specified in the code. Depende sa use or occupancy, and you have this also, another live loads, try to, you have this concentrated load also, and this exponent, exponent, you have to refer this sa obus. So for example, in the office, user occupancy office, then other offices na siya concentrated load nga 9.0 coefficient of 2 or exponent of 2. See section 205.3.3 first paragraph for area of load application, no? Kung asa nimo siya ibutang ang concentrated load. Then we move on to these special loads, no? If you have this use or occupancy, no, then description, then you have to use the provided loads in this table. No, this is table 205-2 special loads, and with coefficient you have to refer to below the table. No, then we move on to this live load reduction. So the design live load determined using the unit live loads as set forth in table 205-1 for floors and table 205-3 method. 2 for roofs may be reduced on any member supporting more than 15 meters square, including flat slabs, except for floors in places of public assembly, and for live loads greater than 4.8 kPa in accordance with the following equation. So this live load reduction, especially for roof, no, design live load determined using the unit live loads as set forth table, may be reduced on any member supporting more than 15 meters square, no, for a roof, but including flat slabs, but except for floors in places of public assembly, and for live loads greater than 4.8 kPa. And the reduction shall not exceed 40% for members receiving load from one level only, and 60% for other members or R, as determined by the following equation. So we have this formula: R is equal to 23.1 times quantity 1 plus D over L. So where A is the area of the floor or roof supported by the member in square meter, D is dead load per square meter of area supported by the member in kilopascal, and L is the unit live load per square meter of area supported by the member in kilopascal, and R is the reduction in percentage, and R is the rate of reduction equals to 0.08 for floors. See table 205-3 for roofs, no? So there is provision that you have to reduce the live load, no, according to this condition. Then we have alternate floor live load reduction as an alternate to equation 205-1. Unit live load set for table 205-1 may be reduced in accordance with equation 205-3 on any member, including flat slabs having an influence area of 40 square meter or more, no? We can use the alternate floor live load. So L is the reduced design live load per square meter of area supported by the member, and A1 is the influence area, no? L sub O is the unreduced design live load per square meter of area supported by the member in table 205-1. But this could be applied kung an influence area having influence area of 40 square meter or more, no? The influence area A1 is 4 times the tributary area for a column, 2 times the tributary area for a beam, equal to the panel area for two-way slab, and equal to the product of span and the full flange width of a precast T-beam. So the unreduced live load shall not be less than 50% of the unit live load, or S of O, for members receiving load from one level only. So nor less than 40% of the unit live load for other members. So in here, will not apply, no, this reduction, live load reduction. So we will kanang adapt what is provided by the table. In your analysis in later part, in your building, no, no need to reduce the live load. No, instead adapt the live load that is provided by the table. So we have the minimum roof live loads. Yes, you have this roof slope or these conditions, then the tributary area from 0 20 20 to 60 and over 60. So the uniform load in kilopascal is this values, no? Depende kung asa. For example, flat na shy exponent ka 3 or rise less than 1 unit vertical in 3 unit horizontal, that is 33.3% slope. Arc and dome with rise less than 1 over 8 of span. This is, yeah, we have these two method 1 and method 2. So we have using the tributary area, and we can get directly from this table the uniform load, no, depende sa condition, these conditions. Then we have this method 2, uniform load in KPA. We have this rate of reduction R and the maximum reduction R in percentage. So using method 2, we have to adapt these formulas, no, this formula if you want to adapt method 2 or method 1. But common koan is method 1. We can automatically but directly adapt the method 1 instead of method 2. For the earthquake loads, loadings, earthquake loads, the scope are structures or portions thereof shall be as a minimum be designed and constructed to resist the effects of seismic ground motion. Seismic and wind design, when the code prescribed produce greater effects, the wind design shall govern, but detailing requirements and limitations of section 208 earthquake load shall be followed. So when it comes to roof or trusses, you have to or the wind load will govern in the design, but when it comes to structures, no, buildings, seismic load will govern, no, in the design. We have this earthquake loads, the design base shear or in the static force procedure. We have this formula. These are actually the design base shear. So dapat among these formulas, no, the total design base shear need not exceed the following. So this is the base shear, no, formula for base shear. This should not exceed the following criteria. This one, no, this one, the total design base shear shall not be less than the following. Also, they will not be less than the following. And in addition, for seismic zone 4, the total base shear shall also not be less than the following. So these variables, so we have this coefficient. This can be found in table. I is the importance factor. Depende sa inyong use sa inyong building or occupancy. R, this is the